Hey guys, welcome back. This is a video where I'm going to go over some of the solutions and answers to the homework on L9 and L10. Okay, and so L9 looks like this. It's here in Canvas. It is books or in the textbook, page 468, and it's these problems. Okay, do not do it in Edulastic. We figured out that Edulastic has created way too many problems for the majority of students in the class. We're no longer doing Edulastic. You're just going to do it on paper like you always did. Take a picture of it, then upload the picture to the assignment for credit. So just to remind you, the textbook looks something like this, right? And page, is it going to let me turn page? No, I guess not. Okay. Page 468 is, and this is frozen. Not sure why. Okay, unfortunately, this is not working too well. There we go. In page 468, we have problems that look something like this. So you had to do 3 through 8, so those are these problems right here. Okay, and in 3 through 6, it says find the value of x, then tell if the side lengths form a Pythagorean triple. Well, what's a Pythagorean triple? A Pythagorean triple is just where the 3 lengths of a right triangle are all whole numbers or integers. Okay, and if you're not sure, just see example 1. Just go back in your textbook to example number 1, which is way back here. Example 3, example 2, here's example 1. Okay, and here's a bunch of common Pythagorean triples. The ones that I want you to remember are the 3, 4, 5, and the 5, 12, 13. Okay, but other Pythagorean triples are the 8, 15, 17, and the 7, 24, 25. Okay, so in this triangle, it gives us some of the lengths. It gives us 7 and 11. There's your short leg, there's your long leg, and x is your hypotenuse. So how are you going to solve that? Pythagorean theorem. Okay, so all you have to do is just go ahead and draw the diagram, okay, like we did here. Okay, x is your hypotenuse, so you know that x is equal to the square root of the sum of the squares of the other two legs, right? X is equal to root 170. Root 170 is not going to give you an integer, so the answer is no, that's not a Pythagorean triple, right? But what about question number 4? Same type of question. Again, you're missing the hypotenuse, but you have 16 and 30. Okay, so x is 34. Okay, well now you have 16, 30, 34. Yes, that's a Pythagorean triple because those are all integers. Number 5, again, you're missing the hypotenuse. So solving, you get x equals 41. That again, 9, 40, 41, that's a Pythagorean triple. Number 6, that is not a Pythagorean triple because root 52 is not an integer. Okay, with number 7, what do? You go ahead and solve, but now instead of the hypotenuse, you're missing the long leg, right? But just solving, so you know that x squared plus 8 squared equals 17 squared. Solving, you get that x equals 15. 8, 15, 17, yes, that's Pythagorean triple. Okay, number 8. Again, you're missing the long leg. Solving, you get root 495. That is not an integer. Okay, so no, it is not. Okay. So number 20, okay, what do we have? We're asked to figure out, well, is this, let me just show you what number 20 looks like. Okay, it says, tell whether the triangle is a right triangle. So now you have these 3 side lengths, and you have to say, well, is this a right triangle? Well, how do you know if this is a right triangle? Well, if a squared plus b squared equals c squared, where c is the longest leg or the hypotenuse, then of course you know that, yeah, that's going to be a right triangle. So let's find out. So here's the triangle. So are these 2 legs squared and added together equal to that? So is 39 squared plus 80 squared equal to 89 squared? While solving, you get 7921 equals 7921. So yes, we know it's a right triangle, so we can add in the little right angle. Okay. Here is number 20. Okay, or sorry, 29. So number 29, you have this baseball diamond, and it says, well, it's 90 feet from home home plate to first base. Then from first base to second base is 90 feet. Okay, and how far would the catcher have to throw the ball from home plate to second base, right? Because the runner is stealing from first to second. Well, this is just a right triangle problem, and this is a 90-90-x. X is your hypotenuse. Okay, so we know that 90 squared plus 90 squared equals x squared, so solving for x, it's about 127.3. The catcher must throw it about 127.3 feet. Okay, that's your answer. Hey guys, hope you enjoyed the video. Some of those other questions you can work out on your own, and hope this at least gave you a good head start or gave you a good check for some of the homework problems that you did. Now let's go ahead and go to L10, which was a worksheet. So I just went ahead and printed the worksheet and did that. Don't worry about these problems. We're not going to do that type of problem, but you have to do all these simplifying problems. Simplest radical form, you guys remember that there's two rules to simplest radical form. No radicals in the denominator and no perfect squares under the radical, right? So go ahead and simplify these first. Well, root 15, 15 is 5 times 3, so that's not really simplifiable, so it just says root 15. But root 20, well, 20 is 5 times 4, and 4 is a perfect square. So 4 comes out of the radical as a 2. So you have 2 times 5, which is 10, and then 5 stays under the radical, okay? So now how do you simplify this? Because you have a root 5 in the denominator. Multiply top and bottom by root 5. So 15 times 5 is 75. And then root 5 times root 5 is just 5. So 5 times 10 is 50. Okay. Well, root 75, that's simplifiable because 75 is just 25 times 3. 25 is a perfect square. So the 25 comes out of the radical as 5. 3 stays in. And then you have 5 root 3 over 50. Well, 5 over 50 is simplifiable, right? Because 5 goes into 50 10 times. So that is 1/10. So you have 1/10 root 3 or root 3 over 10. That's your final answer. Number 2, you have root 8 over root 100. Well, root 100 is already a perfect square. That's just 10, right? So, and 8, well, that's just 4 times 2. 4 is a perfect square, so the 4 comes out as a 2. You have 2 root 2 over 10. 2 over 10 simplifies to 1 over 5, so you have root 2 over 5. Okay. Root 6 over 27. Well, 27 is 9 times 3. 9 is a perfect square, so 9 comes out as a 3. You have root 6 over 3 root 3. You got to get rid of this root 3, so multiply top and bottom by root 3. So you have root 18 over 9. Well, 18 is 9 times 2, so the 9 comes out as a 3. So you have 3 root 2 over 9. Okay, 3 over 9 is 1/3. So you have 1/3 root 2 or root 2 over 3. Okay. The reason I'm going so fast is because you were taught this in Algebra 1, and you were taught this again in Geometry first semester, and you were taught this again in Geometry second semester. So this is all review. That's why I'm going kind of fast. Okay. The root 20, if 20 is 5 times 4, root 4, 4 is a perfect square already. That's 2. So 2 times 2 is 4. Root 20, well, that's 5 times 4. So 4 comes out as a 2. So 2 times 3 is 6. And then root 5 stays underneath there. So you have 6 over 4. That's the same as 3 over 2, root 5. Okay. All right. 4 over root 5, multiply top and bottom by root 5, you get 4 root 5 over 5. Okay, root 4 over 5 root 3. Well, wait a second. Root 4 is 2, but I didn't simplify that. I just went ahead and multiplied top and bottom by root 3. So you get root 12, and now we can take out that 4, right? So you get 2 root 3 over 15. Okay. So find the value of x and y in each triangle. So now we go to our special rights, okay? And we remember that the relationship for any 30, 60, 90 special right is this. So if you have a 30, 60, 90, okay, save 30, 60, 90. Remember that it's x, 2x, x root 3. Okay, so the short leg is x. Okay, the hypotenuse is twice as long as x. And the long leg is root 3 times whatever the short leg is, right? So here we're given the short leg is 8. So remember that the hypotenuse is twice as long. So it's 8 times 2 or 16. And the long leg is just root 3 times whatever the short leg is. So 8 root 3. Number 3, we have the exact same problem, different numbers. So 14, hypotenuse is twice as long, so 28. Long leg is just the short leg times root 3. Okay. Number 4, exact same problem, different numbers. Okay, short leg is 12, hypotenuse is twice as long as that, so 24. Long leg is root 3 times the short leg, so 12 root 3. Okay. Now, number 5, we're not given the short leg, we're given the long leg. Okay. Well, if we go from short leg to long leg, we multiply by root 3. So if we're going from long leg to short leg, we divide by root 3. So x is equal to 12 over root 3. And obviously, you got to simplify that. Root 3 over root 3. So 12 root 3 over 3. So that's 4 root 3. You get 4 root 3 there. And then hypotenuse is just twice as big as the short leg. So it's 4 times 2 is 8. So it's 8 root 3. Same question for number 6. Okay, just slightly different numbers. Okay, they give you the long leg. Okay, so, well, how big is the short leg? We'll just divide by root 3. So 8 over root 3, multiply top and bottom by root 3. So you have 8 root 3 over 3. And then the hypotenuse is just twice as long as that. So 8 root 3 over 3 times 2. So 8 times 2 is just 16. Okay. So now with these 4 problems here, these are all 45, 45, 90 special right triangles. And we remember that the 45, 45, 90, okay, 45, 45, it's x, x, x root 2, right? These two legs are congruent because obviously it's an isosceles triangle, right? Base angles theorem. And then the hypotenuse is longer than the leg by how much? By a factor of root 2, okay? So here we're given 8, so we have 8, 8, 8 root 2. Here we're given 14, so 14, 14, 14 root 2. Okay, and these two, we have to work backwards a little because now we're given the hypotenuse is 18. So instead of multiplying by root 2, okay, we have to go shorter to get to the leg. So we divide by root 2. So 18 over root 2, multiply top and bottom by root 2, you get 18 root 2 over 2. So 18 over 2 is 9, so you get 9 root 2. You have 9 root 2, 9 root 2, 18. Same problem here, different numbers. So 8 divided by root 2 is 4 root 2. So you have 4 root 2, 4 root 2, and then 8. Okay, guys, that's all there is for L9 and 10. Hope you enjoyed the video. Check your answers, and yeah, we'll see you in the next video.